Hello, this is Moneeb Ahmed, a research assistant from National Textile University, Pakistan. The paper I will be presenting today is titled The Individual Utilization Behavior While Using Critical Healthcare Systems. Let me just give you a fast preview of my presentation. We are going to begin with the introduction, followed by literature review, problem statement, research question, and hypothesis. Then moving on the research methodology, and finally the results. We will end the presentation with a discussion on the findings, along with some limitations and future direction for this work, and some references. Considering the topic background, we observed that ergonomics and human factors are the application of psychological and physiological principles to the design of the product. The goal of human factor is to reduce the human errors, increase productivity, and enhance safety and comfort. However, the development in the HCI has shifted to reveal age and gender-related differences in this regard. Here is the question arises, why do we need ergonomics? So the answer could be in the fact that the deficiencies in the HMI cause an increase in human errors. There are three major divisions of causes of man-made errors. Along with the complexity of task and the workplace, the user demographics are the third potential cause of man-made errors. According to the past research, medical errors are known to be the third most common cause of the deaths in the US. Although the behavior of user is highly influenced by UI design, but the processing and perceiving of UI deviated against different human factors such as age, gender, and many more. A detailed literature review regarding user demographics and healthcare machines UI revealed that not a single study has investigated these variables, for most of the relevant studies known were subjective in nature. So there is a need to explore the influence of these variables on the critical healthcare systems. So we tried to answer the question that how these demographics influence the user's performance or perceived workload, specifically for critical healthcare systems. This study has formulated 6 hypotheses. H1, that age will affect the performance while using the critical healthcare systems. H2, that gender will affect the performance. H3, that education will affect the performance while using critical healthcare systems. H4, that age will affect the perceived workload while using the critical healthcare system. H5, that gender will affect the perceived workload while using a critical healthcare system. And H6, that education will affect the perceived workload while using the critical healthcare systems. The research is exploratory in nature, and we have used the purposive sampling technique to select 54 participants, both physicians and nurses from different hospitals in Pakistan. As far as the prototype is concerned, we developed a well-designed medical ventilator, Hamilton C6, in Sublime Text to conduct experiments with 3 pre-decided task scenarios. Researchers highlighted that sample size of about 5 to 15 participants uncovered about 85 to 97% of usability issues, specifically for critical healthcare systems inspection. This sample size adds credibility in our study. Here is how the experimental prototype progressed, starting with filling the consent form and biodata form, then moving to the task 1, task 2, and task 3, followed by the NASA TLX tool for measuring the perceived workload, and ending with the thanks form. For the experimentation, we use this all-in-one touchscreen-based PC as a ventilator. There were 3 pre-decided use scenarios. The experience in the start ventilation task was interpreted as the experience with an unseen interface. In the change setting task, there were some hidden options and some values to recall, and it was comparatively a memory-loaded task. The participants gradually become acquainted with the user interface, so the experience in the change mode task was more familiar. The behavior in the task was interpreted by taking into account the familiarity with the interface. These were the study variables for each selected task, including task completion time, that was the time to complete a task, reflection time, that was the time to take the first action in the task, and the total number of touches. For the perceived workload, a well-known subjective tool, NASA TLX, was used, which measured the perceived workload by incorporating 6 different dimensions, including mental demand, physical demand, temporal demand, effort, performance, and frustration level. These 3 were the dependent variables of the study. Participants were divided into 2 age groups that were young and older adults. Similarly, based on their education, they were divided into physician and nurses group. These charts present how the demographics were distributed based on 3 variables: age, gender, and education. We have selected SPSS as tool to analyze the collected data, descriptive statistics, and one-way ANOVA was used. All the ethics were strictly followed for conducting this research. We inflicted no psychological and physiological harm. Confidentiality was maintained, and informed consent was taken from all the participants. Along with this, the study was approved by the Ethical Review Committee of National Textile University. This graph shows the p-value of different groups for This graph shows the p-value of different groups for different study variables. We can see that the p-value of task 3 completion time and number of touches along with the task 1 and task 3 reflection time in age group is recorded as significant. Number of touches for task 2 in gender group was recorded significant. Moreover, the perceived workload for the education group was recorded as highly significant. We see that the difference in the efficiency were recorded as slightly significant in some variables, though even a small amount of time and number of touches saved per task may be clinically significant, especially when dealing with the critical healthcare systems. In the conclusion, we can see that in contrast to male, female participants perform significantly better on printed safety critical interfaces. In addition to that, the perceived workload was recorded as slightly higher in male participants. Male participants perform significantly better than female participants in memory-loaded tasks. Young adults have better task completion time and reflection time than older adults. However, older adults have committed fewer mistakes and perceived less task workload than younger adults. Nurses perform efficiently on safety critical systems and perceive a significantly low task workload. However, the results of physicians for memory-loaded tasks were better than nurses. Here are some limitations and some future directions for this work. The data collection was carried out at limited geographical venues, and the findings of this study was based on a single critical machine. That was a medical ventilator machine. Therefore, we suggest to need to test these variables for some other machines. The use of hardware such as eye tracking device could be helpful to get more precise results in various other dimensions. There is a strong need to explore the scientific roots for observed behavioral differences. Multiple other demographics and design factors demand the researcher's attention and must be explored. Study findings have substantial implications for the effective user-centric design of safety-critical systems. The findings of this study could help for personalized user experience. There are some references consulted to meet the research objective. Thank you so much for your attention, sir.